Hello everyone. Today I'll be solving question number 27 from 2019 exam. So in this question, we are asked to find out the value of this integral. This is the real integral and we need to find out the value of it. So how we will solve it? We will use the method of contour integration. First we will check the form of this integral, then we'll apply accordingly the contour integration. So in this question, this integral is given to us in this form. This denominator has no real roots. We can see. Yes, there is no real roots. So in this case, what we generally do, we will take a semicircle contour of limit varying from minus r to r. But here in this case, we are given minus infinity to infinity. So fz dz is the contour in the form of minus infinity to infinity cos kx. This is the real part only. So to make an analogy between the real part and a z part, real part is generally x part and analogy between z. So this is e raised to the power iota kz and z square plus a square dz. To solve this equation in fz, we will apply Cauchy's theorem, which says for contour fz dz is equals to 2 pi iota sum of the residues of fz at the poles within contour. So what we need to find out? We need to find out the value, we need to find out the pole value, which is given by putting the denominator equal to 0, which means z is equals to plus iota and minus iota. And now which pole will lie inside this contour? And it is this one, plus iota, right? And how to find out the residue when z is equals to plus iota? So residue is equals to, at z is equals to plus iota, z minus a fz. So z minus a fz is e raised to the power iota kz, z plus iota and z minus iota. In this case, a is plus iota. A is plus iota. So this term will cancel. And we are finding this at residue z is equals to plus iota. So the value will be, residue value will be e raised to the power iota k. Z value will be replaced by iota a. And here it is iota a plus iota a. It is equals to e raised to the power minus iota square ka upon 2 iota a. It is equals to e raised to the power minus ka. Sorry, minus ka, 2 iota a. Now fz dz, fz value is, sorry, fz dz value is equals to 2 pi iota into residue at the pole z is equals to iota a, which we just now got. It is e raised to the power minus ka upon 2 iota a. So 2 iota will cancel. Pi e raised to the power minus ka upon a. Now equate the real part of this contour which we just now solved with this function which is given to us. So it is a real function and the value we got is also a real value. So the answer is, so the answer for cos kx x square plus a square is equals to pi a e raised to the power minus iota ka. So this is the answer, A. Suppose in the final question, in the final result, if we got some value in the form of iota, this is pi e raised to the power minus ka upon a plus eta some value. So then we would have ignored this eta value and the answer would be this real part only. And in case of integral which is given to us in eta forms, then the answer would have been, we would have neglected real part and the answer would have been this part. Okay, thank you.